Hello and welcome to this Haas Tip of the Day. Today we get to talk all about mill soft jaws. Now these soft jaws are like gold. So very useful for quick fixturing. We're going to be sharing some insights, and before the video ends, I'll be showing you the #1 most useful rule that I know of for fixture design. So stick around. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now if you're tightening up those tools by hand, this is a common setup for a vertical CNC mill. 2 vices, a first operation and a second operation. If my parts have long parallel sides to it like this one does, then I might as well just hold that second operation in a vise with hard jaws being supported from underneath by parallels. I'll also make use of a parallel keeper to make sure that those parallels don't go flying out of my vise when I blow off my parts, allowing chips to settle behind there. Now we don't typically mill into hard jaws like these because they're a bit pricey. They're often case hardened and ground on all sides like a 1, 2, 3 block for precision. If your parts are goofy shaped, they can't be held in standard hard jaws, no matter how hard you try. This is where soft jaws come in. Soft jaws are just aluminum or mild steel jaws that are meant to be machined. They're meant to be fitted for your parts. We'll start by making some jaws. Whenever I had a slow day at the shop or needed some busy work to keep my guys going, I'd have them make jaws. These are a machinist's best friend. The cycle time on these jaws is just over a minute and uses only 3 tools. I'll leave the ends saw cut, and I won't even machine off these extruded faces. By keeping them cheap, I'm able to make more of them, and they'll be around when I need to use them to save time for setups later. I'll just file the edges, give them a quick deburr, throw them in the tumbler, or Scotch-Brite them, and we're ready to go. I'm almost embarrassed at how junky these jaws look, but I'm here to make money. These jaws are going to be very precise, but only on the surfaces where I need them to be. We'll want to make sure that our vise is straight. Now this is always important, but even more so if we're going to cut those jaws. If you haven't cleaned your vise in a while, now is a good time. If there are any chips underneath our floating jaw, we want to take care of them. And it only takes a few minutes. Loosen the set screw, pop the jaw off, making sure to grab our half moon spacer. Clean everything, put a dab of grease on the spacer, lightly oil everything and put it back together. Now this screw is really important. You don't want your floating jaws so loose that chips can get between it and the vise. Tighten the set screw, and this is important. Back it off just a little so things don't bind. Whatever vise you have, download the manual and do some quick maintenance. We'll want to keep our jaws as short as possible to avoid deflection, and we need to make sure the vise is clamped tightly before we machine into the jaws. Clamping on stacked parallels can create the spacing that we need. For a taper-free part fit, we'll want to clamp our parallels as near to the top of the jaws as we can get without machining into them. I'll often use empty plastic end mill tubes to hold the parallels, and again, I make sure the vise is clamped tightly on the parallels, just like I tighten the real part. I'll oftentimes just grab a piece of stock and clamp my vise on it before I cut my jaws. This is fine and it works most of the time, 90% of the time. I'll use the parallels and keep them towards the top of my jaws when I really want to guarantee a perfect fit, when I really cannot have any taper in my jaws. Now, here's an illustration for you that'll show you exactly how this taper occurs. If we tried to machine into our jaws without them being clamped on something, the floating jaw would just bounce around, giving us a terrible cut. Clamping on stacked parallels creates the perfect spacing that we need. Now, if we tighten the vise with our parallels near the bottom of the jaws, they'll cut just fine. But it is possible to end up with tapered jaws that don't grip our parts evenly. As the vise tightens against our actual part, the jaws deflect by some amount. With taller jaws, the taper can be drastic. Okay, this is an exaggeration, but you get the idea. If we try to keep our spacers near the top of our jaws, we'll end up with a better part fit. Cutting the jaws under this preloaded condition will eliminate gaps and jaw taper when it matters, when we are firmly clamped on our parts. In real life, we'll want to keep our jaws as short as possible to avoid deflection, but if it can't be avoided, keeping your spacers as high as possible in the jaws will give us a firm, constant part hold. One last check with calipers to make sure our parallels are out of the way of our cut. We'll take the profile of our part and cut that shape right into the jaw. It's a simple process, but there are some pitfalls that we need to avoid. When choosing an end mill to cut your jaws, make sure that it has sharp corners. Jaws that are cut with a sharp cornered end mill, 90 degrees, will allow the part to sit flush each and every time. If we cut the jaws with a tool that has a corner radius, a bullnose tool, the part will be pushed up as the jaws are closed on it. Even a small corner radius on our tool can cause us problems. On some of our parts, these pointy corner radiuses can actually grow or shrink in an exaggerated way based on how our tool wears, or if we're using tool wear offsets. This can cause our parts to interfere with our jaws. If this triangular part is cut undersize at all, it's going to make this radius smaller. When clamping, this pointier corner will be crushed by the jaws, causing the jaws or the part to deform. For this reason, I will usually relieve the radius in my jaws to keep them from pinching my parts in the corners. Watch those radiuses. Now, if we get lucky, our part shape will allow it to self-align as the vise closes. You can see that in this setup, the part has nowhere to go. Oftentimes, we'll want to machine our part stops right into the jaw. On this part, we'll push our part back and to the left when tightening that vise. This brings us to what I think is the #1 rule of fixture making. It's kind of an open secret with tool and die makers when precision really matters. Rule #1, always locate on your datums. Always, every time, 100% of the time. Well, maybe not always, usually. No, well, maybe not always, but we should at least try and locate on our datums. This is huge. This should be foremost in your mind as you are designing any kind of fixture. If these holes have a tight positional tolerance off of datums A and B, then we should be locating off of datums A and B, off of the fixed jaw, not the floating jaw. In this example part, my perimeter has a wide open tolerance. If the part were to grow or shrink a little bit, it would be well within spec still. If the overall part size varies on us, but still staying within print, our hole positions are going to be moving around on us, unless we locate on our datums. Think about it. Have you ever spent all day moving your offsets one way or the other to keep a feature within tolerance? Ask yourself, are you locating on your datums? Are those datums being located up against a solid fixed jaw? As we start winding up here, we want to give you some closing comments. Starting off, it's almost always better to use a steel jaw than an aluminum. And there's a couple reasons. #1, steel lasts longer. It's not going to deform over time for high production. And beyond that, if you do get a chip stuck in between your part and the jaws, we want the chip to stick to the part. So you only mess up and dent one part instead of having that chip sticking to the jaw where it'll dent part after part after part. The chip is going to stick to whatever is softest, the jaw or the part. So harder jaws are better. With goofy shaped parts, we'll often drill and then bore a tooling hole, making it easy to pick up the work offset on these parts the next time they are running. Remember, boring always gives more accurate hole positions than drilling. Now, if you are reusing soft jaws, we can tighten the fixed jaw and just snug the floating jaw. Then clamp on a part for alignment, smack the jaws down with a dead blow, and then fully tighten. Some of you might have noticed that the holes that we put in our jaws are oblonged. We've done this to make the jaws reversible. I can reuse these jaws just by flipping them over and cutting in a different shape. Well, that is about it for today's tips. Thanks for letting us be a part of your success and for watching this Haas Tip of the Day.